So this is the tools for solving or factoring of polynomials that you've used or seen before but may have forgot video. We did just do some of these tools in the last video, but this is also a reminder of different ways you can factor quadratics from Unit 5. We also did this before, but we're just going to go through it one more time because I don't really think some of you still understand what a factor is. And when we do these, when we find these numbers that make the polynomial equal to 0, it is either a root or a 0 of the graph. Those words are interchangeable. It is also a solution that makes the equation equal to 0. It's also known as a factor. So when I say factor, I also mean solution, and I also mean root. I mean every single one of those things. It is also an x-intercept, where it hits the graph on the x-axis. So let's talk about some factoring stuff. So we first did this in Chapter 5, but we can factor with the Mr. Wrap box method. You can also factor these mentally if you don't need a method. So to do the Mr. Wrap box method, you set up your box. You put x squared up here with 6, and then negative 5x goes down here. You put x and x because that multiplies to x squared. And now you need something that multiplies to positive 6 but adds to negative 5. So that's negative 3 and negative 2. Check your work by cross multiplying. And it adds together. Therefore, the factored form of this is x minus 3 and x minus 2. The next way we did was with the giant x. When we're factoring with the giant x, so where was I? We were factoring this with an x. So this is, we put 12x squared on top, negative 12x squared, don't forget the sign. And then x down here, you multiply this and this together to get the top, which is negative 12. I have to think of something that multiplies to negative 12 and adds to positive x, which is 4x and negative 3x. So then I change the grouping. I do 6x squared plus 4x minus 3x minus 2. I group the first two together and the last two together. I factor out a 2x from the first two to get 3x plus 2. I factor out a negative 1 from these to get 3x plus 2. We do grouping right when we get the same in each parentheses. So you end up with 2x minus 1 and 3x plus 2. You put what's outside of the parentheses in one set and what's inside the parentheses in the other set. Now this one says solving quadratic polynomials by completing the square, which means we're not going to get a factored form. It means we're going to get solutions, or x equals something, and that's okay. They're all interchangeable. So by completing the square, the first thing you do, 2x squared minus 4x, you separate the variables from the numbers. Oops, I don't want to use that color. Come on, Mr. Ducharme. The next thing you do is you cannot complete the square when there's a number in front. So I'm going to divide it out. I get x squared. No. X squared minus 2x, I have to divide everything by 2, equals 8. So now I'm going to complete the square. X squared minus 2x plus blank equals 8 plus blank. So over here, I do b over 2 squared, which is negative 2 over 2, or negative 1 squared, which is 1. Now I can write this or factor this using that number inside right here, that b over 2, as x minus 1 squared equals 9. Oh, we're going to get a nice number. Isn't that nice? You take the square root of both sides to get x minus 1 equals plus or minus 3. So x minus 1 equals 3. X minus 1 equals negative 3. So x equals 4. And x equals negative 2. And if I wanted you to write those as points, we would write that as 4, 0, or negative 2, 0. And that's how you solve using, remember, you look for those keywords. If it says solve, you're looking for the x equals part or the points. If it says factor, we're looking for it in factored form like this, where it's still a polynomial. Last but not least, we have that quadratic formula. If we can't factor, we use this as our last resort. So I look at this and it can't factor, unfortunately. So I have to do the quadratic formula up in the corner, and there is a song. I'm not going to sing it on your recording. But I get x is equal to negative b, which is 1, plus or minus the square root of b squared, which is negative 1 squared, or 1, minus 4 times a, which is 1, times c, which is negative 3, all over 2 times a, which is this 2. So that ends up being 1 plus or minus the square root of 1 plus 12, which is 13, all over 2. Now if that root would simplify, we'd simplify it, but it doesn't, so we can just leave our answer like that. If everything was divisible by 2, we'd divide it by 2, but it doesn't. Sometimes you can also get imaginary numbers, but we can't. Okay. The last chapter 5 thing, before we get into those chapter 6 things you just did in the notes, is the difference of squares. So the formula is x squared minus a squared equals x minus a times x plus a, up in that corner. So the square root of 4x squared is 2x. So this would be 2x minus 1 and 2x plus 1. Again, that's just one of those formulas you need to know. And if you're one of the type of people that wants to know why it works, just start multiplying that out to check your work. And you'll notice that you'll get rid of that middle term. That's why there's no middle term. Another set of formulas that we talked about, but now kind of upping it for chapter 6, is the sum and difference of cubes. So I told you you had to know these, and you do. But the way I always remember them, just because it's kind of hard, is if we look at the original sign, it always goes, original sign, it always goes same as the original sign, different from the original sign, and then plus. So same, different, plus. So when we do the formula, we look that I have a minus in the middle. This is 3x cubed minus 2 cubed. And I did tell you at some point you should take a second and memorize 1 through 5 cubed and 0 through negative 5 cubed. So when I write this, I keep the same sign in the original set of parentheses, 3x minus 2, same sign. And then the different sign, so this is going to be all pluses. I square what's in parentheses, so 3x squared is 9x squared. So again, I just did 3x squared. And then you do plus 3x times 2, which is 6x. And then 2 squared, which is 4. So again, it's always same sign, different sign, plus. So we did same sign in the first set of parentheses, different sign, plus. And that is our final answer. Again, just kind of another formula you have to know. Factoring by grouping is very similar to how we did it with quadratics, just without the big x part. So if we have something that already has 4 terms, we can group these two together and these two together. Out of the first two, I can factor out an x squared, and I'm left with x minus 1. Out of the second two, I can factor out a negative 1 to get x minus 1. And I'm left with x squared minus 1 outside of the parentheses and x minus 1 in the parentheses. I should notice at this point too that x squared minus 1 is a difference of squares, so I can keep going. You get x plus 1, x minus 1, x minus 1. Now, just to take a note, you can also write that as x plus 1, x minus 1 squared, because there is 2 of them. And that's going to be more helpful at the end of Chapter 6 than it is right now. Next would be factoring a greatest common factor out. And if I'm looking at it, I see that they share a 4x squared, so I'm going to pull that out first. And I'm left with x squared minus 4. I notice that I snuck yet another difference of squares in there. I like sneaking those in there. So this also factors to x minus 2 and x plus 2. Some other examples of factoring. We kind of talked about being able to factor something that looks like a quadratic with the x. So let's just test it out here. I need something that multiplies to 9x to the 4th and adds to negative 10 x squared. And looks like that, looks like that is negative x squared and negative 9x squared. So if we put this together, we get x to the 4th minus x squared minus 9x squared plus 9. So out of the first two, I can factor out an x squared, and I'm left with x squared minus 1. Out of the second two, I can factor a minus 9, and I'm left with x squared minus 1. So when I put what's outside in the parentheses, x squared minus 9, and x squared minus 1. Now I snuck 2 difference of squares in there. This is x plus 3, x minus 3, x plus 1, and x minus 1. Whoa, rude, Mr. Ducharme. So many. Last but not least, you can also do factoring by grouping when there's an even number of terms. So if I look at this, I can actually group these two together, these two together, and these two together. So out of the first two, I can factor out a x to the 4th, and I'm left with 2x plus 1. Out of these two, I can factor out an x squared, and I'm left with 2x plus 1. Out of these two, I can factor out a 1, and I'm left with 2x plus 1. So if I rewrite that, I get x squared plus, x to the 4th plus x squared plus 1 and 2x plus 1. You're going to have to take my word for it that this one doesn't factor. So, deal. But those are your extra examples of factoring. If you need any other factoring help for this unit, please let me know. Shoot me an email and we'll go over some more examples. Thanks for watching this video. Have a great day.